Okay, so this is the second in the two parts of trying to understand why mass numbers are decimal. We talked about why atomic numbers are whole and why mass numbers are decimal. Briefly, I talked about the isotopes, shifting the mass number. I talked about protons not being exactly the same mass as a neutron. I talked about electrons having a mass, which we generally ignore, but eventually, once you look at the more precise mass number, you realize that the electrons are having an effect. Finally, I mentioned right at the end that the final reason is something to do with E equals mc squared. So what does E equals mc squared mean? It means that energy is equal to mass times this value c, which just so happens to be the speed of light in a vacuum, but we don't really need to think about it as that's just going to be distracting. Let's just think about it as just a universal constant, and that the size of that number is 3 times 10 to the power of 8. Okay, yes, the unit is meters per second, but we don't want to be distracted by it being a speed. Just think about it as a number, 3 times 10 to the power 20, 3 times 10 to the power of 8. So, and when you square that number, we're going to have, so all of that squared is going to equal to 9 times 10 to the power of 16. And if you want the units, it would be meters squared per second squared. But again, we're not interested in the units. We're just interested in seeing how does the energy convert to mass. This would mean that what it's trying to say is if I had 1 kilogram of mass, I would then multiply that by 9 times 10 to the power of 16. And then, so let's just forget the units for a moment, actually. And obviously that's just, we can now ignore the 1. And so we can see, therefore, that 1 kilogram would be that many joules of energy. So, so what does it mean? Well, it really means that mass and energy can be interchanged, can be swapped back and forth. And we see this in nuclear reactions. We see this, this is why the sun hasn't burnt out a long time ago, because it uses something called fusion, which is converting mass into energy, and then that energy is radiated out as electromagnetic radiation, which helps us to give us light and warms our planet. So what's this got to do with this extra mass? Well, basically, sometimes one element might be slightly more massive, will have more mass than another element, because it has more energy inside of it, and when it converts to another element, it will actually some of that mass will be converted into energy. So let's look at a chemical equation over a nuclear equation over here. So we were looking at alpha decay. Here we go. Let's look at this one over here. If you want to just follow me, and then you can have a look where I am right now. So we looked at polonium decaying into lead, and it gives off an alpha particle. Now, if we add up all the, I've just used whole numbers here, but if we added up the mass number before and afterwards, they equal the same. But when you look at the decimals, you'll realize it won't actually equal exactly the same, because also what's being given off here is energy. So we've got energy is also released when this happens. The alpha particle will have a certain amount of energy, and so will the lead. And I'm not sure if it gives off a gamma ray as well. It might do. But where did that energy come from? It must have been there beforehand, because we can't just produce energy, and that's because it was wrapped up inside of this, and it actually contributed to the mass. So the mass of polonium. So in other words, this 211 won't be quite 211, but it'll be, and these won't be 207 and 4 exactly. But these numbers here, once you look into a bit more detail, will actually be less than this number over on the left, because this number on the left, we had energy. So basically, that the mass is just like another form, like a sort of static form of energy. So when you pick something up, you're holding energy, but in matter form. So that's the reason why those numbers are like that.